You know, we tend to think of the vacuum of space as, well, empty, nothing. But what if it isn't? What if it's a real physical material, something made of countless tiny grains? Today, we are diving into a pretty wild new idea called the single bulk framework. And it proposes exactly that, a mechanical universe that in theory you could actually touch.
So, this one question really gets to the heart of one of the biggest debates in all of physics. For about a century now, the popular image has been space-time as this smooth, continuous fabric, kind of like a rubber sheet. But this new theory is asking us to completely rethink that. It wants us to imagine reality at its most fundamental level as something more like a pile of cosmic sand, a granular material whose collective properties give rise to literally everything we see.
All right, so here's how we're going to break it all down. First, we need to understand the deep, fundamental problem that modern physics is facing. Then we'll look at the two rival camps that have been fighting over how to solve it. After that, we'll get into this radical third way, the idea of a material universe, and see how its simple mechanics claim to solve, well, everything. And finally, we'll get to the ultimate test, the one that could prove if it's right or wrong. Okay, so for all its incredible success, you have to understand that modern physics is kind of built on a fractured foundation. We have these two absolute powerhouse theories that describe our universe, but here's the kicker. They just don't play nicely together. In fact, they fundamentally contradict each other.
So on one side, you have Einstein's general relativity. It gives us this beautiful, elegant picture of gravity and the cosmos. But for it to actually match what we see out there, we have to pretend that 95% of the universe is made of this invisible dark matter and dark energy that we have absolutely no direct evidence for. Then, on the other side, you have the standard model of particle physics. It's ridiculously precise at describing the quantum world, but it depends on 19 totally arbitrary numbers, constants that we just have to measure and plug into the equations by hand, with no clue why they have the values they do. It's like having two perfect instruction manuals for reality that are written in completely different languages.
Now, to try and fix this big disconnect, physicists have pretty much split into two rival camps. And this division, it's not new. It goes all the way back to the ancient Greeks. First, you've got the geometers. Think string theory. They believe space-time is the fundamental, smooth fabric of reality. But this path leads to some really weird mathematical problems, like the infinite density inside a black hole, and this baffling idea of a landscape with 10 to the power of 500 possible universes, and we have no way of knowing which one is ours. Then you have the atomists, who take the total opposite view. Reality is pixelated, it's discrete. But they have a really hard time explaining how a blocky digital reality can produce the smooth, continuous world we all experience. Basically, both roads have kind of led to a dead end. And that brings us to the single bulk framework. It's proposing a third way, a path that kind of merges both ideas. It suggests that, in a way, both camps were right, and also wrong, at the exact same time. So here it is, the core hypothesis of the whole thing. Space-time isn't fundamental. It's not the bedrock of reality. Instead, it emerges from the collective behavior of something deeper, a universe that's jam-packed with countless, microscopic grains of reality. Okay, and the best way to wrap your head around this idea of emergence is with water. Just think about it. We know for a fact that at the micro level, water is made of individual, discrete H2O molecules. But when you get trillions upon trillions of them all interacting together, the smooth, continuous properties of a fluid just appear. It's not magic, it's just collective behavior. The SBF is basically saying the universe works the exact same way, discrete grains at the bottom, smooth spacetime on top. Now, to get a little more specific, the theory says the vacuum is in a very special state called a jamming transition. The easiest way to picture this is to think of a huge pile of sand that's right on the verge of becoming a solid. It's disordered, but it's also rigid. In this critical state, all the little grains are so interconnected that a tiny push in one spot can trigger a chain reaction, a kind of avalanche that zips right through the whole system. And that, right there, is how the theory explains long-range forces like gravity emerging from purely local interactions. Okay, so that's the big picture, but let's dive into how this mechanical universe is actually supposed to work. I mean, how do you get all the incredible complexity of reality from just a pile of cosmic grains? And this is basically the blueprint for the entire theory. Don't worry, we're going to break it down piece by piece, but just look at the flow. It all starts from that one central idea. a granular vacuum made of tiny Planck-scale grains. And from that single starting point, the theory claims everything else just emerges naturally. It branches out to explain all four fundamental forces as simple mechanical stresses. It says particles are just little knots in this material. It even claims to solve dark energy and makes predictions we can actually go out and test. Let's start with the one number that supposedly governs it all. The entire theory, the whole thing, is governed by one single geometric number, z. It's called the coordination number, and it's approximately 14.4. Now, all this number represents is the average number of neighbors that each tiny grain of space touches. That's it. From this one number, the entire beautiful structure of physics is supposed to emerge. So how does that work? Well, check this out. In this model, the four fundamental forces of nature stop being these mysterious, abstract fields. Instead, they become simple, intuitive, mechanical stresses in this granular vacuum. Gravity? That's just the material expanding. The strong force holding atoms together? That's just tension. Electromagnetism? That's just a twisting force or torsion. It's basically high school mechanics, but on a cosmic scale. Okay, so if forces are just stresses, then what are particles? Well, the theory proposes that they are essentially stable knots in the fabric of space. Think about a persistent tangle in a fishing line. And just like different real-world knots have different properties, these different topological knots correspond to different fundamental particles, like electrons, muons, and so on. Now, this is where it gets really, really compelling. By calculating the complexity of these different knots, the SBF can actually predict the masses of particles from first principles, no fiddling required. And as you can see, its predictions for the muon and the tau particles are just shockingly accurate. We're talking an error of less than 0.5%. This isn't just fitting data after the fact. This is a direct calculation from pure geometry. It's pretty incredible. So, a theory that unifies forces and particles, that alone is impressive. But can it tackle the big, nagging mysteries of the cosmos that have stumped physicists for decades? Well, the single bulk framework claims it absolutely can. And what's so cool here is how the theory gives these concrete physical answers to what have always been very abstract problems. Remember dark energy pushing the universe apart? The theory says that's just stored stress. They call it geometric frustration, from all the cosmic grains trying and failing to pack themselves into a perfect crystal. The terrifying infinity at the center of a black hole? It's gone, replaced by an ultra-dense but finite crystalline core. And the legendary weirdness of quantum measurement? The theory says that's just the moment the granular vacuum is put under so much stress that it literally breaks, forcing reality to pick just one outcome. But of course, look, a radical theory is just a nice story unless you can actually test it. And this is where the single bulk framework really puts its money where its mouth is. And this is exactly what makes it real science. The SBF isn't just a cool thought experiment. It's a proper scientific theory because it makes specific, testable predictions. If those predictions turn out to be wrong, then the theory is wrong. End of story. And the amazing thing is, these tests are happening soon. As early as 2027, the LIGO Gravitational Wave Observatory could detect echoes bouncing off those crystalline black hole cores the theory predicts. But the real definitive test, the big one, is set to come around 2035. That's when the Lightbird satellite will be looking for a very specific sawtooth signal in the faint afterglow of the Big Bang. It's a signal that should only exist if this mechanical universe theory is actually correct. The entire philosophy behind this whole framework can really be captured in this one simple phrase. It's all based on the idea of topology, which is just the math of shapes that stay the same even when you stretch or bend them. The theory argues that the most fundamental truths of the universe must be similarly unchangeable, similarly robust. By grounding physics in topology, it's trying to build a description of reality that isn't just one possibility among millions, but is, in fact, geometrically necessary. And that really leaves us with a profound final thought to chew on. For centuries, we've been searching for truth in the elegance of abstract mathematics and super complex equations. But this theory suggests we might have been looking in the wrong place entirely. What if the fundamental code of the universe isn't an equation, but a shape? Not an abstract field, but a simple, physical, mechanical structure? Well, with a little luck, we might just find out, and very soon.